So.
All right. So a few weeks ago, I bought a new MacBook Air, and I walked in, and twice in 3 days I broke Lion, and it wouldn't log in. So I walked into the Apple store, and the guy says, "You tried to install VMware Fusion on your laptop?" And I said, "Yeah, like, what's wrong with that?" And he goes, "Dude, like, you can't do that. That's not on the approved list of software. What would make you think to install an unapproved piece of software on your machine?" And I was like, "Gee, I don't know."
I believe the word he used was logically.
Yeah, logically, why would you do that? And Ted goes,
So I walk up, I'm like, well, I have a MacBook here, and I installed VMware and Lion on it, and it worked fine. So using induction and that as our base case, we then abstracted that out.
And he goes, "Whoa,
whoa.
I don't want to hear about induction, okay?" And then he goes, "Lion is a completely different architecture than Snow Leopard." And I was like, "Really? Is it? Can you explain that, please? Because I'm pretty sure it's not." And then there was the other Apple Store genius, looked like Adam Young from Owl City, and he was like, you guys need to calm down." So at this point, I'm wearing an RSA shirt, and Ted's wearing an MIT shirt, and it's like, you want to talk about logic? Come on. But all right, so we're gonna get started.
Ready? All right.
Because it's 2:30.
Wait, there's one thing to do first.
All right, cool.
I'd like to present Mike and Ted.
Bill had an accident, so I replaced him with Mike. If you want to know about the accident, hit me up later.
How many of you guys are students? All right, awesome. This is for you guys. How many of you guys are professors? All right, awesome. This is also kind of for you guys a little bit too. How many of you guys just are bums? All right, screw you guys. So our goal is we want every university to participate in cyber competitions, and we're going to help you help us to realize that goal, and we have a tool that's going to help you get started and help us realize our goal.
We think. So what's the problem? So we think there is a problem, and we think that universities and institutions are trying to teach their students how to be hackers, but they're not doing very well because we're transitioning from traditional computer science where you learn theory and you try to do practical events at the end, and we're shifting into a cyber world, a cybersecurity world where it's pretty much all practical, and then you kind of have to absorb the theory yourself. So, we've been introducing all these information assurance classes, but we're struggling to try to fit this gap between high level and practical knowledge, and we still see a problem there because the instructors are being pushed into this realm, and while they're trying to give and demonstrate practical examples, they're not really experienced with the new cybersecurity world that we are in right now. So, there's a bunch of great stuff. If you go to IEEE's website, if you pay for it, and you look under the CCERT conference or CSET conference, you'll see tons of white papers of different universities trying to implement cyber labs. And they have varying success. What we've done is we've gone through all that and we looked at their conclusions, and we've tried to build a tool that helps them realize all their conclusions. So again, not all universities have these cyber labs, and to kind of replace them or offer something similar to all universities, there are cyber competitions out there. There are tons of them. We're not going to list them. If you go to CTF competitions or something, or if you go to the DEFCON website, you'll get a good list. But there's also a problem with these cyber competitions. They're trying to isolate the best from the rest, so if you're not first, you're last. They're pretty difficult. So and not all universities have access to them, and whether they don't know or the students don't have enough people to create a team, or they're just afraid of them.
So if you read our slides that we submitted for the disc, you'll see we said something about prizes. And so throughout the presentation, we're going to be asking questions, and if you give us a good answer, we're going to give you a prize. Now, it's pretty easy for you to get a prize from us.
So who wants a prize? That guy right there in the hat right there. Come here.
So he's getting an RFID wallet. That's about how easy it is to get prizes from us. So about that problem, you hear problems all the time. School doesn't teach you much practical knowledge, blah, 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 like who really cares? You hear that all the time. You need an outlet for practical learning, blah, blah, blah. Who gives a shit? You hear that all the time. So enter CTF competitions. CTF competitions are a practical outlet for your real-world knowledge, and they help you assess your current skills and help you realize what skills you need to work on more. But they can be hard, and no one wants to get completely pwned. Total pwnage.
So if you remember our goal, we want all universities to compete in these competitions. So why? These competitions introduce students to critical thinking. Whether they're winning the competitions or they're solving a few challenges or they're not solving anything, they're either realizing what they don't know or they're able to evaluate what they do know and what they do very well. So we'd also like to use these competitions for universities to augment their assessments. So instead of you sitting down for standardized testing and answering A through D, we want to use these critical thinking skills and even your improvement. So if you're not that great at them, if you're entry level coming in and you're not solving too many questions at first, and then towards the end of the year you're solving a few, or you're getting farther in the questions than you were, we can definitely show improvement there, and we can actually assess critical thinking and an improvement in critical thinking. And finally, we can evaluate the curricula that the university has. So instead of just, we have like 5 to 10 universities who have teams that are participating and doing well in these competitions, we can get every university, and we can actually see some universities who are better at web exploits, better at binary reverse engineering. So if you're in high school, and I hope if you're in high school and you know that you want to go into this field, if you could sit down and say, I really like web exploitation, or I'm really into the web, I can pick a university who performs well here. So how do we do this? How do we make competitions less hard? How do we make all universities adopt these competitions? Do we want to ask the competitions to standardize their challenge scoring so that we can evaluate students across competitions? Do we want to ask them to put a tiered structure to the competition so that they have an easy mode, a medium mode, and a hard mode? That doesn't really work too well. So there's a third option. We can do it ourselves. And the way we want to do it ourselves is through standardizing the practice. So standardizing what you do as a university or you do as a team so that we can actually compare results across competitions. So it's practice, man. We're talking about it.
Talking about practice.
A little East Coast there. Now West Coast, actually. So again, how do we do it? Let's standardize and systemize our practice. And we're going to hopefully show you how to do this so we're not just kind of shooting in the dark there. And when we do this, we're going to remove a fear of the unknown. So if we have a standardized way of practicing, teams that or universities that aren't into competitions, they don't know what the competitions are, they won't be afraid. We'll give them a method. We'll say, here, use this. It'll direct you. It'll show you the competitions you want to compete in. It'll show you the questions that you should be answering. And then instead of having the objective of going in there and winning, we can have universities redefine that and say, our objective is to learn at first, right? Not just to win. So if we change our motivation, we might change the outcome of separating the top-tiered schools from the rest of the guys and actually show some performance on a per-student basis. And then after the university is kind of used to it and they've competed a few times, they can switch back and they can actually play to win.
So we're hypothesizing that a collaboration tool will help you compete and help you collaborate with each other more successfully. So can anyone name a collaboration tool that you could use? Okay, all right. IRC is decent. We'll give that. So this is like TV jammer kit thing. So you build your own TV Beanle, right? So right, we have some solutions we tried were like Redmine and MediaWiki, not Google Wave, whoever said that, which are slow and syntax overhead, and there's a lot of syntax overhead, and it's good organization of content, but bad collaboration, so there's a lot of version and conflicts. And then you have Google Docs, which is great on the collaborative side, but not so good on the challenge management side. So like good computer science students, when we couldn't figure out what a good solution was, we built our own. So So now we developed something called RTFn, Rock the Flag Network, and it's a software-hardware collaboration, tracking, storage, etc. solution. And what it does, it organizes data and preparation materials before the competition, and you can compound them after the competition for materials that you've gathered for preparation for future occurrences of that. It also creates a repository of tools and software that you'll need to use during the competition to save time from constantly having to go download them every time you need them. I know there was like 4 competitions we competed in where we had to download Padbuster every time, and that was just annoying. It has real-time challenge management functionality based on AppJet's Etherpad, which is what Google Docs is based off of, which we've customized to include things like related file uploading if there's a binary for binary analysis, challenge ownership so you can tell who's working on what and that every challenge is owned by someone, tags, labels so you can grep and search for them later for practice. Also, it has reporting and trending functionality to show you visualizations of your progress and where you need to improve and how your attempted improvements have worked. And we have some examples of that in a few slides. So this is kind of just a visualization of what RTFN actually is. So if you'll see, you input into it your challenges, your tools, the dates and deadlines of these competitions, and your actual skill, your participation. And what goes into it on the bottom, or what is RTFN, is in the orange there, and that's the labeling, the tracking, the searching, the reporting functionalities, the storage of tools, and all that. And what you get out of it is increased campus involvement, because now you have more people competing from more places all over campus, because you don't have to be in a central location anymore. You can identify your weaknesses better because you know what works and you know what doesn't, and you have all these pretty graphs that Facebook would love that identify that for you. You can trend your challenges. You can effectively prepare based on all these documents that you've created. And if you look at this next slide, it's pretty cool. So this would be an example of a graph that you can get from RTFN. So if you notice on the left-hand side, you have minutes to solve web exploits. So you're noticing for the first few challenges, it's taking about 100 minutes to solve. And then you hit point 1, and you dramatically drop to point 2. And you say, like, what changed? What did we do that changed that and allowed us to improve? And you can diff all the things, and you'll see tags will include something like Burp Suite. And using that allowed you to do web challenges 3 times faster. Now, Burp Suite is just an example. It could be anything. Like, for example, if you go to minutes to solve binary analysis, if you look at point 1, up to point 1, you're taking about 30 minutes to solve it. And then you go up and you hit point 2, and now it's taking you 2 hours. And then you go back down to point 3, and it's taking you half an hour again, pretty dramatically. And you want to see what changed. How can we level that out so that that doesn't happen again? So if you diff all the tags and all the editors, you'll see that up to point 1, Nick was your binary analysis guy. Then Bob came in, and Bob sucks. So then you kick Bob out of there, and now you have Nick back. So you know, like, Nick is your binary analysis guy. So this helps you identify what you're doing, how you're doing it, and who is your guy to do that. And it also identifies, listen, we just lost Nick. Now we need another guy for binary analysis, and that helps with recruitment, and et cetera. So now we're going to do a quick little demo. So Ted's going to get out of there, and he's just going to log in to, or well, he can explain it. He's a big boy.
Where is that?
You're right there?
No, I don't know where to.
We're from Stevens Institute of Technology, which is in Hoboken, New Jersey. It's right across the water from the financial district in New York City. So we've competed in competitions like Seesaw, CCDC, ICTF, Carnegie Mellon CTF, RU CTF. So we've done a bunch of CTFs. You want to maximize that?
That's good.
So this is, Ted can explain.
So this is kind of what it looks like. Right now it's kind of hanging off of the screen a little bit, but so you'll get all the competitions that you've competed in. If you want, you can go up and create a new competition, and that'll live at a new DNS entry, and then we'll name it and get a start and an end date. And we'll come back to the contest. We'll go into this one. We've populated a little bit. So you populate all of this yourself, and it'll be like a per challenge thing. So we've gone and entered something called TCP/IP, and that's a protocol decode, and Mike was working on it. So as you go into it, you can see these things. So like this is, Mike just joined here. He's got it on his laptop, and he's going in and he's editing. And this is all, we're all using Etherpad to do this. We just modified it a little bit. So Mike, if you want to go ahead and solve that challenge. So he solved it, and now now it comes back. If I would say, you know, Mike, you didn't solve it, I can go ahead and uncheck it for him.
And then we can say, oh, we realize like this is a really hard challenge. So,
yeah.
You can't see my screen, but I just clicked hard.
Yeah, so these ones would be considered hard. So I'm going to go back to, and we'll go into the DEFCON CTF quals here. And we'll pull up this guy. So if like you want to enter a picture, you can go ahead and drop that in there. I entered a honey badger because he's really badass. So that's pretty much what it looks like. We're still working on it a little bit. If you want to, you can come in and check all the challenges list. And then we have like all the owners, all the people that worked on it. We save every single update. You can just add a Twitter tag in there, just a pound tag, and it'll go ahead and enter that for you.
So if you notice that challenge dashboard, when you saw all the list of challenges, you can categorize them and you can see. So going into a challenge, if you know, hey, it started a few hours ago and I know that I'm the binary analysis guy, I'm going to walk in, look at that dashboard, say, what's binary analysis, what's not being worked on, and I'm going to get on that right now. So next, this is a little implementation we did. We got an aluminum toolbox from Sears and drilled some holes in it, created some ports in it. We both used to work at our school's IT department, so we've been doing that, like ports and stuff for forever. So we have like a little switch in there you can see. We have a little microcontroller that you really can't see, and you can just connect to that, and that's like your mobile CTF box. So we competed in Seesaws at NYU Poly, and we had to go there to compete. So this is something that you could bring with you if you have to go somewhere to compete. And this isn't like the de facto implementation of what you have to do. This is just like an example of what you can do with this distribution.
Yeah, so like Mike said, we're releasing it as a distribution, so you just go down and pull the ISO and then launch it up. And we're not going to do it as a virtual machine because it does have functionality to load your own virtual machine. So if you're playing like an attack defense competition like RUCTF and you have to load a virtual machine, you would go ahead and do it here. So there are security mechanisms that would protect anyone coming in, connecting to it. So like if it's running like an OpenVPN client and then pushing everything out to you, so you would connect into this. The virtual machine would be there. You wouldn't have to load it on your own computer. So we don't recommend releasing RTFn or implementing it as a virtual machine. So why do we think this might make a difference if we're going to switch back into the goals where we want every university to be competing in these competitions, and we want to use these competitions to evaluate and allow the university to mold them into their assessment. We're going to enable team collaboration with this. So even if you're not all sitting together, if you're around the world, if you have a team that's not, if you have a university that's not all co-located, or you have a team that's not co-located, if you have a team built from many universities, we can effectively do that now. And then we can extract metrics from the competition. So we can extract times when you added tags. We can times when players were added, whether you're actually finishing the challenges, or what challenges you're not finishing, what challenges you're finishing quickly. And then we can compare student performance with and without RTFn. So we can imagine a situation where a university wants to say, do cyber competitions actually help students in academia? And we can compare a group of students who are playing capture the flag or cyber competitions, and then a group of students that aren't. And then we can also, now with this tool, compare students who are collaborating and students that aren't. So we can say, we can give a group of students who are competing and a group of students who are competing with this tool, and we can compare their performance.
So another quick opportunity for a prize. Can anyone name a way that they could use RTFn that like we haven't, that would help them out at their school? Anyone? This is like the best prize.
You can think
like
about
you
it.
Want this prize. Yeah, you can think about it and get back to us.
Get to us after. So come up here, come up to the stage right afterwards.
Team projects? What do you mean by that? So working on a team project together? Right, that works. Yeah, absolutely. Right. She said, so the answer was team projects when you have people in a team that are co-located that aren't with each other that have to work on online team projects. So you're going to get a $100 Apple Store gift card. That's your prize. So awesome for you.
So to kind of finish our lofty goal, what we want you to take away from what we are imagining is we want any and all students to be participating in cyber competitions. I added college there, but definitely high school too, and even after college. We want competitions to be used to augment university curricula. We think that could be a very, very powerful tool. And if you don't agree with us on that sense, I mean, you can still use RTFn if you're currently playing cyber competitions and you don't want to see the world to change, but you just want to do better. Or on the other sense, remote red teaming. So I know a lot of these competitions involve what's called a red team that will come and actually play against the students. So the students are being measured by how well they can fend off a red team. Well, it's very difficult for a red team who are often working professionals to come and sit down together. So, and then even to share information. And we've been talking to a few people who are really making a lot of progress in this. We think we might be able to help them out here using this tool and being able to provide remote red teaming collaboratively.
All right, so I don't think we have time for questions, but we can take it to the Q&A room, so come hang out with us, and we'll give you cookies. And you can come get your prize from us.